Hello everyone. This is going to be my little introduction video to CalcPlot3D. It is an app and it is a tool that we are going to use very consistently in class this semester to help us visualize things in 3 dimensions. It's also something that I hope you find useful outside of class and use it on your own when you're either trying to understand concepts or doing homework or studying for a test or something like that. So first, just where to find it. You can either follow the link on Canvas or you can simply Google CalcPlot3D. It is the first thing that shows up. So this is what the app looks like. Um, this is just kind of the default function of a surface that we see pictured here in 3D, but it's not actually what I want to start by talking about. I want to talk about where you can find help if you have questions and I'm not there to kind of troubleshoot or something. You can go to the help manual. It has a lot of information. So for some of our early things, CalcPlot3D objects, right? So these are the things that you can add. So if we look here, add to graph, it talks about all of these different things right here. So the one that we see right away is a function of two variables, the z equals f of x, y. So that's what this one is. We'll see a few more here soon, but you can add a bunch of different things. We're going to talk a lot about vectors in this class. Vector fields are toward the end of the semester. Parametric surfaces also toward the end of the semester. Regions are something you may have seen in Calc 2 when you're kind of like revolving things and doing a volume of solids of revolution. We'll also use it when we're talking about double and triple integrals. So lots of useful things here. And as you kind of go throughout the semester, you'll find certain pieces here very useful. So that's one place to look. Another place, if you go to the project website, then this is kind of the home page. So this is all created by Paul Seeberger from Monroe Community College. And so this is his little website. And so if you just click on CalcPlot3D intro video, this is the one I wanted to draw special attention to because as you can see, there's a whole lot of stuff that is there. But the intro video is a 24-minute video, as you can see down here at the bottom, and it just kind of goes over some of the basics and what you can do in CalcPlot3D from the creator himself. My video is not going to be nearly that long, but I'm going to try to at least talk about a few of the capabilities that it has. Okay, so let's go in ourselves and just see what are some things we can do here. So some basics first of all, you can enter functions without using like times here. So notice it's just 7xy. I've used it as 7xy. You do need to use parentheses correctly. So if you want your exponent to be x squared plus y squared, it does need the caret for your exponent, but then parentheses around those. And the nice thing is, if you are unsure if you have graphed things correctly or written things correctly, then you can just look and right under it prints it out. And so you can see if it's the function you truly intended to have. This is what this one looks like. It's pretty interesting, which is why it's the default one. It's got some maxes and some mins, some peaks and some valleys and some interesting behavior. If you want to start playing around with the 3D thing, so I'm just clicking over here using my mouse. You can do some click and drag stuff, which I'll talk about in a second, but it's really nice sometimes to just use your arrow keys. So here I'm just clicking right and I'm rotating along. Right? If I click left, then I start going clockwise and rotating. You can also rotate vertically. So if you press up or press down, you can rotate things so that you can see certain places. If you want kind of a weirder angle, maybe something like this, you can't really get from just doing the arrow keys as easily. You can always click and drag, which is what I'm doing now. If you want to set it spinning, you can click and drag and then release, and then it'll go until you click to stop it. If you ever want to get back to that original default view, you can press the home key on your keyboard. For me, this is on the little number pad and on the number 7, but I have a Dell. A lot of people may not, but when you click the home button, at least on a PC, not sure what Macs have to be honest, then it goes back to this default view. Um, some things you can do to change the view a little bit. So one, if you ever want to look through something, this is more useful when you have maybe a couple surfaces. You can click the magnifying glass here and make it transparent. You can also remove the grid lines by clicking E, it removes the edges. You can also click F to remove the face of the surface and just leave the grid lines. That one you'll probably never use, but I do like this sometimes for maybe a specific type of picture that I'm looking for, but often the grid lines are kind of helpful. Um, you can zoom in and zoom out. I'm going to show you some quick ways to do that, and then some longer but more specific ways. So you can zoom in by just clicking the plus. And what this does is it just cuts in half all of your bounds. So basically this goes, 1, 2. Now if I zoom in, it goes 1/2, 1. If you zoom in again, it's going to go 0.25, 0.5. You can see down here in the negative z-axis. And you can tell, right, that by zooming in, this is already like not at all recognizable as our original surface. And so I'm going to zoom back out twice to get to the original. You can also, of course, zoom out, and you can see it goes to 2 to 4, then 4 to 8, then 8 to 16. And suddenly, if you zoom out enough, it basically just looks completely flat here. So if you want to be a little more specific, then I'm going to show you a different example here. So if you want to click or unclick, so if you wanted to keep this around and just not have it show, you can unclick this, and then you can either press enter once you enter something, or click on the little box to make it reappear. You can remove it entirely by clicking the X. I'm going to bring it back here. This is the default, and then I'm going to add another one. So here I'm just adding a function, z equals f of x, y. And I am going to specifically use z equals x plus y cubed. And then click enter. It looks like this. So this shouldn't surprise you that the z coordinate grows rather rapidly, right? It's kind of like going off with a very steep slope. This is because of the y cubed, right? Your z is growing much, much faster than your x and y here. So certainly I can zoom out, but this still just looks really vertical, and doesn't really help me see the cubic nature. I mean, I kind of see the little wave, of a cubic, but it's kind of hard for me to see what's going on. If I zoom in more, then I mean, I'm really only seeing stuff right around the origin. I don't know that this is really helping me. It doesn't even look like it grows that much. So I'm going to go back to, here's my default. I clicked home. So something you can do to change the bounds and like mess around with your axes is click on this thing next to graph. It's the blue grid, and it says display format axes panel. So here, let me zoom in a little bit. Whoops, sorry, zoom out. Okay, this was my default view right here. So notice that when I clicked in and out, you were seeing how these all changed. They're just literally being cut in half every time, or here multiplying by 2 when I zoom back out. So one thing that we could do is our z grows a lot faster than the other ones. So let's go like -5 to 5, -5 to 5, and then since I get up to cubed, 5 cubed is 125. So let's go to like -150 to 150, and let's just see what happens. So I'm going to click enter here. Oh, well, that doesn't look very useful at all. And the main reason is, well, two things. First, our scale factor. So basically, if we want to scale our x and y to kind of match our z, so they're like 1/30th, I can scale these each by 30, and suddenly I have like a cube again and not something really, really tall and thin. But I still have this nasty, like, black dark markings around the z-axis, this is coming from the z-tick. Basically, every little mark from negative 150 to 150 is being marked just like this, -5, -4, -3. So you're seeing 300 things, and so it's just overloaded. So uh, let's see, that marks 1, so there are 10 of those. So let's just do 30 here as well, I guess. Oh, that looks much nicer, right? So suddenly that issue is gone, and we can look at this. But I have an issue. I said that this should go up to like over 125. Why doesn't it? So this comes from the z-clip. So the z-clip literally cuts off your surface or whatever you're graphing at that z value. So we're only seeing things between heights -4 and 4 here. So I'm just going to make these the same as my upper and lower bounds at 150 and -150. And now you're going to see the whole thing. And here you can see how much this looks like kind of your normal cubic graph that you're used to seeing when you just graph like y equals x cubed in 2 dimensions. So this is something that can help, especially if you do F1 in our first PWA, then this is something that could be really useful for you. So these are just some things you can do with messing around with scaling. Maybe the last thing I'll talk about here is these quick views. So our default view, this is the crappy thing that I started with. So here, let me actually just restart. So if you go here, so that's our default view. If you want to look in the first octant, that's when everything is positive. So our x, y, and z are only allowed to be positive, so you're only getting that one little piece. So if we go back to the default view, you're only getting this hump here in the front. And so that's the first octant. If you want to look at just the positive z, you can. And so you have a bunch of different possibilities, right? So here's just positive y. So these are some of the quick ones you can do. And then if you want something a little bit more customized, then you can go to that display format axes panel and screw around there. Okay. So hopefully that is helpful. I know it's a lot of information just to get the basics of graphing, but if you just play around for a little bit, I think it becomes pretty intuitive. So like I said, hopefully that's helpful, and you will have many little 2 to 5 minute videos to come as things become relevant in class.